Welcome to our second tutorial on the introduction to Arduino. My name is Afikile, and on our first tutorial we looked at what an Arduino is, what it can do, and some of the projects that we can do with an Arduino. And if you have not seen that video, I will put a link on the description below. And for this second tutorial, we are going to look at a very simple project. And we're going to connect an LED and turn it on and off. We will connect a few cables. We will also look at resistors, and we will also use a breadboard to achieve that. So before I just explain what everything is that I spoke about, we want to create a new circuit. Just make sure that you have selected circuits on the in this section here, and then you can create a new circuit. And so basically we'll start a new project. So once we come in here, we want to rename our project, and we can do that by, you can click on this amazing Ladi, and let's rename it and say turn LED. From this panel here, we want to then select an Arduino. We've selected an Arduino here. We are going to also use what we call a breadboard. Basically, what a breadboard is it's basically a, can I please call it a device that gives us access to more pins. So you will see that there's positive, negative, and then there's A, B, C, D, E, E, F, G to J, and then there's positive, and then there's a negative on the other side. And if you look at the breadboard, you will see that there is this solid line right in the middle here, which basically tells you that what happens on this side of the fence is only known by this side of the fence. That side of the fence does not talk with these guys on this side. So what we see is that there are holes that go from A all the way to 30. So B to 30, C to 30. But how this one works is that if you connect your pins, these ones here, they are connected this way. Is it vertically? Yeah, they are connecting vertically. And then if you look at the negative and positive, they connect horizontally. So there is a line that goes all the way down to the bottom here, and there's a line that goes all the way down to the bottom on this side. But when you come to this section, the line is going vertically. So it only goes this way, and it doesn't go that way. So, and thirdly, we want to get an LED. So this is our LED, and our LED uses, I would say, about 1.7 to 1.8 volts. So it uses 1.7 to 1.8 volts, and I stand corrected, but that's how much I've read about it and the ones that I have used. And from the previous tutorial, we would have known that our Arduino can supply, our Arduino supplies 3.3 and 5 volts, but we will see that. So what happens is that because this is a 1.7 volt and our Arduino gives us between a 3.7 and a 5 volt, which then tells us that that is a bit, that's more current that the Arduino is giving us to power the LED. So you will find that even though it might not blow your LED now, if over time your LED might blow prematurely because you are giving it too much voltage, you are giving it too much, there's too much current that is going to that LED. So in order to make sure that there is enough current we send enough current that is needed by this LED, we are going to use something we call a resistor. So every component, for instance, that we use in our Arduino, it uses a current. We have components that use 5 volts, some components use 1 volt, some components, they use different voltages. I think a sensor, for instance, I think the sensor uses about, I think it uses 5 volts. Yes. So every component that we are going to connect to our Arduino uses a voltage. And too much voltage can cause problems in the long run, and too little voltage is not going to be enough for our component to work. If we have a component that we want to plug into our Arduino that has less current than what the Arduino supplies, we use our resistor. And the resistor is to limit the amount of current that goes to our LED. So we want to make sure that we don't send 5 volts to this LED, but we send enough current that is needed by this LED. So that is what we are going to be looking at in this tutorial. We now have a resistor, we have an LED, and now what we want to do, we want the ability to communicate with our LED. So what we are going to do is to take we are going to look at our breadboard, and we said this is negative. So we are going to connect the negative to our negative here on the breadboard on the Arduino. By the way, if you click here by mistake and you say, let's say you made a mistake, you can press escape on your keyboard. So for instance, I want to double click here to make this cable neater, and I want to double click here to make it neater also. You will see that when it makes a cross, it means that your line is straight. So now our line is straight, just to make it neat. So now we have connected our negative ground, our ground to our negative on the breadboard, and we are going to also connect our 5 volts to our positive pole, but we'll do that at the end. And then in fact, we can do it now because it's not connected anyway. So we can connect it, if you can permit me to connect it this side. There is a way that we can jump from this negative of this positive to that side, but just to make things neater for this sketch so we don't get confused, if I can then make it neat, I'll change this and make it red, and I'll change this and make it black. So we now have our circuit. So now we want to connect our resistor. We have our resistor. If you want to turn it around, for instance, let's say you wanted to put it this way, you can turn it, but you will see that once we come and connect it here, it takes up all the pins. It takes the whole real estate there. It uses up all the pins. It doesn't give us space to move around. So what we'll do is that we will make it horizontal. So we come then and we connect our resistor in any of the pins that are available to us. Then we have, if we can, let's put it here. So we then come and we are going to connect our LED to the breadboard itself. So what we want to do is that we are going to connect, if we want it, let's put it this way. So now we've put it in the breadboard. I think you may have seen this image. You can see that we've put, for instance, we have placed the pins inside in the breadboard itself. So now we've also placed our LED in the breadboard, and we have a positive, we have a negative this side, we have a positive this side. So what we want to do is to connect this positive side to our Arduino, because we need to be able to talk now to our Arduino. So we are going to connect it to pin number 13, because that's the pin that our code comes standard in or with. And if we can just make it a bit neat, sorry for the crossed lines. So now we have it connected, and let's put a yellow line, a yellow communication line. The last thing we need to do is to connect our LED to our negative. You can see that it's not connected anywhere. So what we want to do is to take our cable, we plug it into the negative there. So then we can make it neat. There, it's connected to our negative. So you will also realize that we could just connect it directly to our negative onto the Arduino, but that defeats the purpose, that because when we have other, let's say we had other 13 other LEDs, we don't have enough space for them, so that's why we use a breadboard. So the last thing that we need to do is to come and open the code, and we are going to use text, only text. And so it is already done for us. We can see that it's done for us. And sorry, the one thing that I didn't show you, what we also need to do is to change the resistance. And we are going to make this 320 ohms. Okay, then you will see that whenever we put a different value, let's say 310, you will see that the resistor changes color. Okay, so what we are going to do now is to look at the code, and we are going to start coding our Arduino. And we come to code. You will see that it comes standard as blocks and text, but we just want text, just only text. Let's click OK. And what you'll see is that it says it has this code that has been given to us. It has void setup, pin mode, void loop, digital write, high, delay, and then digital write, low, delay. So basically what this means is that, or rather, every section of code here means something. So when we look at void setup, it is basically a section where it gives us the opportunity to tell, let's say we had 2 LEDs in pin 13 and pin 12. So we can tell pin 12 that, okay, you belong to this red LED, and let's assume we had another LED, a green one, and we can say pin 12, you belong to the green LED. So when we come and say pin mode, what pin mode is it is a way that we use in the Arduino to configure a certain pin, or to tell a certain pin how to behave, whether to behave as an input or as an output. So we see that there is void set up, we have pin mode, we have void loop, we have digital write. So what happens is that each pin on our Arduino has a mode. It can either be an input or an output. And what that means is that it can send signal out to a device that is connected to the Arduino, or it can receive information from outside, from the device itself, and it receives it as an input. So the pin mode is a way that we use in the Arduino to tell a specific pin how to behave, whether the pin is going to be an input or that pin is going to be an output. And in this case, we are saying pin mode, pin 13. So which is this pin 13, you are going to be an output. So you are going to send information out. And we then have this void loop. What digital write does, it is used to write whether the pin is high or low. So we have this digital pin. We want to know whether it is high or low, and high or low in the Arduino is on or off. If it is high, it is on. If it is low, then it is off. So, and then you see void loop. All that this is, it says, you Arduino, everything that is inside this void loop, you must just keep repeating it. And so you will see now it says digital write. So digital write basically is just saying write this code to Arduino to this pin, right? Write this code to this pin, which is what code? Put it on high, which is put it on, and then wait for 1 second, and then you go and write this code which says put this LED off. So this is on and then this is off, and then you can also wait another 1 second, and then you go back and you restart, you put it on, wait 1 second, you put it off, go out, you go back in, you put it off, you put it on, you put it off, you know. So and so now then you can click on start simulation, and you will see that it starts blinking. Can you see that it starts blinking? Okay, so it shows us that our code is working. The final thing that we are going to do in this tutorial is to look at changing the time for that our LED blinks. We can see that it blinks, it goes on for 1 second and it goes off, goes on for 1 second, goes off for 1 second, because our code says go on and then wait for 1 second, and then you go off for another second. So let's look at if we wanted perhaps to make it half a second. Sorry, if we have to stop the simulation. Let's make it quicker by half a second. So now you'll see it will blink faster than it was. So you can at home try and change this value as you want to do so. We have come to the end of this tutorial. Thank you very much for listening, and we covered a few things in this session. We looked at a breadboard. We looked at what it does, or at how we can use a breadboard. We looked at a resistor, and we said that a resistor, it limits the current that we send to our components that we have plugged into our Arduino. And we have an LED, which we said has a current of about 1.7 to 1.8 volts, which then needs a resistor to protect it from being damaged, because we don't want to send 5 volts to that to the LED itself. Then we saw that we have these cables, which we call jumper cables, and we said the black we usually use for ground, and then the red we usually use for our current, and other colors we use as communication cables. This actually should have been black. Stay tuned for the next tutorial. If you don't want to miss any updates, please subscribe to the channel, and if you like this video, just please give it a thumbs up. Thank you.